Design and analysis of cylinder head of 6-stroke SI engine for weight reduction. Abstract: the term 6-stroke engine has been applied to a number of alternative internal combustion engine designs that attempt to improve on traditional 2-stroke and 4-stroke engines. Claimed advantages may include increased fuel efficiency, reduced mechanical complexity and/or reduced emissions. These engines can be divided into two groups based on the number of pistons that contribute to the 6 strokes. The present paper deals with design of cylinder head with air cooling system for 6-stroke 6-cylinder SI engine. The main objective of design is to reduce weight to power ratio and will result in producing high specific power. Keywords: internal combustion engine, 6-stroke engine, cylinder head. Introduction. In 4-stroke engine, the inlet valve opens I.V.O and the fresh charge of fuel and air mixture is drawn into the cylinder. Then the intake and exhaust valves are closed, and the piston is at its lowest position B.D.C. During the compression stroke, the piston moves upward compressing the air-fuel mixture. But before the piston reaches its highest position T.D.C, the spark plug injected the air-fuel mixture and the mixture ignites, increasing the pressure and temperature of the cylinder. The high-pressure gases forces the piston down, which in turn forces the crankshaft to rotate, producing a useful work output during the expansion or power stroke. At the end of this stroke, the piston is at its lowest position, and the cylinder is filled with the combustion products. Next, the piston moves upward again, purging the exhaust gases through the exhaust valve and down a second time, drawing in fresh air-fuel mixture through the intake valve. Thus the piston completes 4-stroke, which gives 2 complete revolutions to the crankshaft. But in 6-stroke engine, the exhausted gases which are left after combustion is further used. Then water is injected in superheated cylinder. Through hot gases the water changes its phase into steam as the temperature of the hot gases is high. This steam will works as a working fluid which will forces the piston down. This movement will give an additional 2-stroke for the same cycle. In this cycle, there is no need of external cooling system as the water will cools the system. Less fuel is needed and also increases its power. It reduces the weight and complexity of the engine's head by as much as 50%. Torque is increased by 35% and also increases its efficiency. The 4-stroke block, pistons, and crankshaft remain same. This combination of 2-stroke and 4-stroke technology is named as 6-stroke engine. 2 + 4 = 6. Functionally, the second piston replaces the valve mechanism of a conventional engine. Literature review. This prominent lesson explains the beneficial aspects in a 6-stroke engine which does not exist in a 4-stroke engine. The major difference between 4 and 6-stroke engines are the extra 2 strokes. Bokinala Rajakumar and Abdul Salime. The engine weight has reduced by 37 kg from a base one of 162 kg, excluding engine oil. This corresponds to 23% weight reduction. As shown in the component weight ratio of the materials are 53% steel for the weight-reduced engine, 86% in the base engine, 33%, 13%. Aluminum alloys 7%, 1%, plastics and elastomers, 6%, 0%, other lightweight materials such as titanium alloys and magnesium alloy, and 1%, 0%, ceramics. The material substitutions applied for the engine structure component represented by a cylinder is no more than simple weight reduction. But, when applied this to several moving and functional components, it not only weight reduction method but also contributes to improve engines and emission performance. Shivam Agarwal. A 6-stroke engine portrays various extraordinary approaches in the interior ignition engine to catch the squander heat from the 4-stroke Otto cycle and use it to control an extra power and exhaust stroke of the cylinder. Just as removing power, the extra stroke cools the engine and expels the requirement for a cooling system, making the engine lighter and giving 40% expanded productivity over the Otto cycle. The cylinders in a 6-stroke motor go here and there multiple times for each infusion of fuel. G. Bahadur Vala and Krishna Vaini. They have design and assemble cylinder and cylinder head. They used two different aluminium alloys 6061 and 7475. Abhishek Mode A. They analyze of heat transfer crosswise fin surfaces using software. They thought that experiment-based research done by different researchers in the past is a time-consuming process. Bmr Krishnakant.m and Mr. Srinivas.da. A cycle of 6 strokes out of which 2 are useful power strokes due to its thermodynamic cycle and a modified cylinder head with 2 supplementary chambers, combustion and an air heating chamber, both independent from the cylinder. Several advantages result from this, one very important being increases in thermal efficiency. Chinmayekar Malkar, Vive Crowd. The aim of this research is to understand the latest trends in internal combustion engine while maintaining its prime focus on 6-stroke engine. Mr. Amal S. Bhagat and Professor Rahul Sakarkar. Cylinder head is one of the parts of I.C. engine which is responsible for maintain temperature. One end of it close. It contained the inlet and exhaust valves through which the air-fuel mixture entered inside cylinder and exhaust gases escaped to the atmosphere from the cylinder. In the combustion chamber there are peaks of combustion pressure and temperature on the order of 15 MPa and 2500 K. The heat fluxes and temperature no uniformities lead to thermal stress, which further escalates mechanical loading from combustion pressure. Objectives? The dramatic problem is faced in the conventional engine is that when high temperature present inside the combustion chamber some of the fuel may unburn so emissions is high. It involves emissions like HCCO NOx etc. The heat produced inside the combustion chamber is conducted to all engine parts. Due to this thermal efficiency is reduced. The weight of an engine is also increased. To reduce weight to power ratio and will result in producing high specific power. To design of cylinder and cylinder head is aluminum alloy that is LM13 like 5052. To analyze a new 6-stroke design which adds a second power stroke, resulting in much more efficiency with less amount of pollution. 3.1 Finite element method. The principle of the method is to replace an entire continuous domain by a number of subdomains in which the unknown function is represented by simple interpolation functions with unknown coefficients. Discretization or subdivision of the domain. Selection of the interpolation functions, to provide an approximation of the unknown solution within an element. Formulation of the system of equations, also the major step in FEM. The typical Ritz variational and Galerkin methods can be used. Solution of the system of equations. Once we have solved the system of equations, we can then compute the desired parameters and display the result in form of curves, plots, or color pictures, which are more meaningful and interpretable. 4. Methodology. Principle of 6-stroke engine. A 6-stroke engine describes a number of different approaches in the internal combustion engine to capture the waste heat from the 4-stroke Otto cycle and use it to power an additional power and exhaust stroke of the piston. Designs either use steam or air as the working fluid for the additional power stroke. As well as extracting power, the additional stroke cools the engine and removes the need for a cooling system, making the engine lighter and giving 40% increased efficiency over the Otto cycle. The pistons in a 6-stroke engine go up and down 6 times for each injection of fuel. The 6-stroke engine has 2 power strokes, 1 fuel, 1 steam, or air. The currently notable 6-stroke engine designs include Crower's 6-stroke engine, the Bajulaz engine and the 6-stroke engine. The Bearhead engine is called a 6-stroke by its designer but stands apart from the others. It uses a second opposed piston in each cylinder which moves at half the cyclical rate of the main piston, thus giving 6 piston movements per cycle. It does not use any additional working fluid. After the exhaust stroke, instead of air/fuel mixture, as in case of petrol engines, fresh air is sucked into the cylinder from the air filter, and is removed during the 6th stroke. The valve overlaps have been removed and the additional 2 strokes have been provided for better scavenging, using air injection. The engine shows 40% reduction in fuel consumption and dramatic reduction in pollution. Its specific power is not less than that of a 4-stroke petrol engine. The engine can run on a variety of fuels, ranging from petrol and diesel to LPG. An altered engine shows a 65% reduction in CO pollution when compared with the 4-stroke engine from which it was developed. Modification in 6-stroke engine. Modifications are done to specific parts of conventional 4-stroke engine so that the new engine with 6 strokes works successfully. These modifications are: crankshaft to camshaft ratio modification in conventional 4-stroke engine. The gear at crankshaft must rotate 720 while the camshaft rotates 360 to complete one cycle. For 6-stroke engine, the gear at the crankshaft must rotate 1080 to rotate the camshaft 360 and complete one cycle. Hence their corresponding gear ratio is 3:1. Camshaft modification in the 6-stroke engine. The 360 degree of the cam has been divided into 60 degree among the 6 strokes. The exhaust cam has 2 lobes to open the exhaust valve at 4th stroke, first exhaust stroke, and at the 6th stroke to push out the steam. Cam follower modification. The bottom shape of regular follower has the flat pattern, which is suitable with the normal camshaft for 4-stroke engine. When reducing the duration of valve opening from 9,000 to only 6,000, the shape of the follower must be changed from flat to roller or spherical shape. Working of 6-stroke engine. Different working strokes of a 6-stroke engine are: first stroke, suction stroke. The inlet valve is kept open. Due to cranking, piston moves downward, which results in the formation of a pressure difference due to which pure air enters the cylinder. Second stroke, compression stroke. The inlet valve closes and the heating chamber valve opens. The piston moves upward due to cranking, forcing air into heating chamber. The air at this stage is converted to high pressure. Third stroke, first power stroke. The combustion chamber valve opens and gases of combustion enter the cylinder. Fourth stroke, exhaust stroke. The exhaust valve opens. The piston moves upwards and the exhaust gases are removed via this valve. Fifth stroke, second power stroke. The chamber valve opens and the pure air, now at high pressure and high temperature, enters the cylinder, which does work on the piston and hence it moves downward, resulting in the second power stroke. Sixth stroke, second exhaust stroke. Finally the combustion chamber valve opens. The piston moves upwards, forcing the pure air into the combustion chamber. Conclusions. The 6-stroke engine cylinder and cylinder head has been analyzed under thermal analyzing for different materials. Aluminium alloy 5052 is compared with the existing material, which is aluminium alloy 6063. In thermal analysis among the two materials, aluminium alloy 5052 was good compared to other material. In modal analysis, aluminium alloy 5052 has obtained good results compared to aluminium alloy 6063 material. From the analytical factual results and the analysis result, we get the values of stresses produced in cylinder and cylinder head due to application of temperature and pressure are within permissible limit. Hence we concluded that the basic design of cylinder and cylinder head is safe with reference of pressure and temperature basis. Due to the use of lightweight material, i.e. LM13 with 60-65-50-52 cylinder bore coating, we can effectively reduce the weight of cylinder and cylinder head with improved strength. Also, due to the use of air cooling system, an efficient and faster cooling of engine achieve.